For this section, we are going to learn to convert into a logarithm. Now, what is a logarithm? A logarithm looks like this. And what it does, it helps you solve exponents like this. Now, you could look at this and hopefully see the answer. But what we're going to learn to do is convert these into something called logarithms, and then logarithms we're going to learn properties of them, and logarithms help you solve more complicated exponents. These are easy ones. Logarithms help you when they can become more complicated. So we're going to start with easy ones and build from there. So for this one, I'm going to first look at that and go, what is x? Well, 3 to the what power is 81. Hopefully you can see x is 4. Okay, that was an easy solve. Done. But we're going to learn to change it to a logarithm because a logarithm tells us stuff more when it gets harder. Okay, so to change to a logarithm, what you do is you write the word log. The base of the exponent becomes the base of the log, and then you kind of switch these two right here. So the 81 goes here, and the x goes here. If you look kind of carefully, don't you see right here that thing with these two switched? If you look at this formula up here, you can see the formula, but basically you're switching these two, and the base of the exponent becomes the base of the log. Now this right here is actually equal to 4. This is a lot easier to see and understand. This is like, what? But you're going to get used to how to solve these. All right, let's do this one. So for this next one, you can see that x equals 3, because 5 to the third is 125. But let me change it to a log. So this is going to be log base 5, and then we're going to switch these two. So it's 125 equals x. So this as a log is written like this. Now the value of this is 3, and we'll learn that as time goes on. This is saying 5 to the what power is 125. But we got to learn, first of all, how to convert them. All right, now look at these things inside the box. If you have a log without a base, that base is base 10. If you have this ln that pops up, that is a base e. Now what is e? E from now on is a number. E is approximately 2.718, and it pops up a lot with exponents. So there's going to be some e bases, which becomes ln, and some base 10s, which are base nothing. So some things you're going to get used to with logs as we get farther and farther into these problems. So looking at this one, hopefully this next one, hopefully you can see x equals what? Well, hopefully you can see here that x to the what is 1 over 100. Hopefully you can see it's negative 2. A little bit harder there. Now, let's write this as a log, because that's what we're really trying to do. So log base 10, and you switch these two. So it would be 1 over 100 equals x. Now, let me rewrite that a little bit better. Really, this is log. Since it's base 10, we leave the base off, and we just put log 1 over 100 is really how you write that. That's actually a little bit better. Okay, because we don't write base 10. See right here? Base 10s become no base. So this is a better way of writing it. And this equals negative 2. All right. So this next one here becomes log base e of 1 equals x. Remember, we switched these two. All right. And then, so that's my answer. But if we look right above, you'll notice anything log base e is ln. So really this is ln 1 equals x. So that is how you rewrite e. Base e is ln. See, it's right here. Now, what does this equal? Well, e is about 2.78. So 2.78 to what power gives you 1? And if you think about that, hopefully you can see that actually equals to 0. Because isn't anything to the 0, 1? Oh, yeah. So ln 1 is really 0. And you'll get better and better as time goes on. The key, again, is yes, these problems are easier to see. Just look at them. But we need to learn to convert to these for when they get more difficult, because in these you can find when they get more difficult and get the actual values, which end up being decimals and all sorts of stuff like that.